Hello guys, my name is Parsha Dongre. I am from MIT OE. Today I will be teaching you about 4:1 multiplexer using Verilog. So let's start. Introduction to multiplexer. So what is multiplexer? A combinational circuit that selects one of multiple input signals and forwards it to a single output line. So what are the selection lines? The selection lines are they control which input is sent to the output. So these are the key points. Like a MUX takes multiple inputs but provides only one output based on the selected inputs. The selection lines are binary coded, determine the active inputs. What are the examples? Commonly used in data routing, allowing specific data to reach a designated point in a circuit. So, what is MUX? The 4:1 MUX is a combinational circuit which has four input lines like D0, D1, D2, D3, and there are two select lines which is S0 and S1. So there are one input only which we can write as Y. So what is the function of 4:1 MUX? It selects one of the four inputs based on the binary value of the selection line and forwards to the selected input to the output. So these are the two diagrams in which there is block diagram and truth table. So block diagram as we have discussed earlier, there are four inputs to the MUX, 4:1 MUX. So we have taken D0, D1, D2, D3 as four inputs. There are two select lines as D0, S0 and S1. There is one output. So coming to the truth table, there are two select lines. So we have to write truth table according to it. When S0 has 0 and S1 has 0, then the output Y will be D0. When selection line will have 0 and 1, then output will be D1, 1, 0, output will be D2, and when there are both 1, then output will be D3. So what is Verilog? So guys, as we know, today I will be coding this 4:1 MUX in Verilog. So what is Verilog? Verilog is a hardware description language (HDL) used to model electronic systems. It allows designer to describe the structure and behavior of digital circuits in a textual format. So let's discuss 4:1 MUX coding using Verilog. So we will go to Xilinx software. Yeah. So this is Xilinx software. First, I will teach you basics of it. Like we have to create a file, new project. We have to write some name. We can write it as MUX. Next, next. We have to create new source. Then we have to select Verilog module. Write name. We can write it as 4:1 MUX. Yeah. So next, we have to select input. We can write it as D. It will go from 3 to 0. Then we have to select lines. You can write it as SEL. It will be input only. It can go to 1 to 0. Then we have to select the output. We can write it as Y. It will be output. Then we have to do next and finish. But guys, we have created earlier, so I will cancel it. So after doing finish, you will get like this syntax over here. Though we have to code here, I will explain first the syntax. Here we have created a Verilog module. So there will be a file name. The three terms will be there. There will be one input and it will vary through 3 to 0, which are four inputs. Then there will be a input which is called as selected lines. Then there will be a output we can code here. Yeah. So this is we can assign y means in output as SL equal to B00. 2B means it's 2-bit value. So here there is a see that there is truth table. So when the 00 is there, then output will be D0. When 01, then output will be D1. When 10, then the output will be D2. When 11, then the output will be D3. Coming to the its RTL diagram, see this is the RTL diagram you can see here. Then there are four inputs as we discussed earlier. Then there will be two select lines and one output. So we can come to the test bench code. While creating test bench code, you can get this syntax only. Then after this, you have to code here like this. When input D equal to 4B. 4B means what? 4-bit value, which is 0001. Then it will go to the select line, which is 00. Then there will be a delay of 100 ns. Then as it is, we can write it like that in 4 input format. Then 0010 will be assigned to the 01, and again we will apply the delay. Then 0100 go to the select line of 10. Then 1000 will go to the select line of B11. Then again there will be a delay. After doing that, we have to see the simulation. You can see the simulation by going to the behavioral simulation, then clicking on it. You will see the simulate behavioral model. Then you will go to the simulation. As you can see here, there is a select line. There is line. We can select it and we can see the input and output. So when the select lines are 00, the output will be D0 of 1. As we can see here, while writing truth table, we have assigned 00, which output has D0. So see here, the select lines of 00, the output is D of 0 equal to 1. So the first cases are clear and correct. So we will see the second case. See, there is 01, then the output will be D of 1 equal to 1. Means this case is also correct. Then we will see the third case where 10 is equal to the D of 2. This is also correct. Then we will see the last case, which is both are 1, then the output will be D3. So we have done all the correct steps and done the code correctly. Thank you guys.